All right. Well, thanks everyone, and thank you, Suzanne, for the opportunity to speak at Perforce on Tour today. My name is Samuel Kahn, and I'm going to be talking about game development with Perforce. And before we started, I wanted to know how many game developers we had in attendance, just to know if we have people that will be interested in this topic. And otherwise, if you're not doing games, then hopefully you might learn something today about why games are using Perforce and how we're uh, making the best of our workflow with it. So I'm going to talk about what we're doing at Darewise, but indirectly using another project, and I'm going to show you how we've set it up to work as efficient as possible. A little bit about me first. So my name is Samuel Kahn, and this is the best picture I had in store for today. I was originally a game engines architect. I worked a long time at Ubisoft and Crytek in that capacity, and my focus was on specifically workflow, the editor part of making games, and that comes as well with the source control workflow, how we basically work on a day-to-day, but also how we build and how we deploy our games to the players. And these days, I am the CTO and co-founder of Darewise, which is an upcoming gaming startup studio based in Paris, and we're working on Life Beyond, which is a massively multiplayer online game using Unreal Engine. So the game is live right now and free to play. It's in a state that I would call open development. So brace yourselves if you're going to try it, but I encourage you to sign up and try it anyway. I also do a little bit of blogging and research, and one of the topics that I get into a lot is source control. So on my website, cancode.com, you will find a study that I did recently on source control specifically applied to game development. And I guess this is also partly why I'm here today. So I'm going to go into why we chose Perforce as our solution for source control. And then I'm going to go into the three main pillars that I think you should set up if you're going to set up a game studio, which is, of course, how you configure your Perforce depot, how you configure your continuous integration, and finally, how we're using Helix Swarm for code review. Did we get results, Suzanne?
Yes, we did. So we had a 50% in the gaming industry and 50% not.
Okay, that's perfect. So at least there are some customers for my talk.
Yeah.
So first of all, why do we choose Perforce? I mean, Perforce is well known if you're in the games industry. It is the industry standard, and I think pretty much every major gaming studio uses it. But why is that? And I think the reason is that game projects have very specific challenges that might be a bit different from other types of software engineering. So I'm going to go into that a bit. The first thing is that a gaming project is very, very large. It's a monolithic project that can be up to several hundreds of gigabytes. That is not an uncommon file size. I run a pretty small studio, and our project is above that size. On top of that, you will have terabytes of work files, which are files that are used to author the content of the game. So they will be files that are used by external applications, but they are something that you want to version anyway. And because of that sheer amount of data, you really want to have single file operations. So you want to be able to essentially submit a change to a single file or get the latest revision of a single file. Again, because syncing the entire depot could be very, very lengthy. And tying into that, we have a big need for performance, again, because we have very, very large depots. So most source control being optimized for text files, but in our case, this is not really the majority or the bottleneck in our workflow. So we really need something that is optimized for binary files. Another aspect that is pretty uncommon is that in general, the majority of your contributors in a game project will not be programmers, and they will have a harder time understanding source control concepts. So what they need is a really good user experience or even a total abstraction from the source control. Yeah, the reality of our project is also a bit different. We are very, very rarely doing. Sorry. Okay. We're very rarely doing open source development. And what we really need is a centralized single source of truth where we're going to be doing trunk-based development, again, because we have a lot of binary files that cannot be merged. We're going to need file locking, and we're going to need access control as well for confidentiality. And finally, it is very common for game development to be distributed using co-development and bringing external studios to help ramp up and finish a project. So we're going to need scalability that not all source control will offer. So essentially, this is why we choose Perforce. I mean, I'm not going to go into a deep comparison here, but what I can say is that the strengths of Perforce really align with the needs of the games industry. So that's kind of a perfect match. It is fast and scalable. It has some of the best user experience and tools, and in this case, I'm referring in particular to P4V. It offers a centralized workflow, single file operations, and file locking. So that's exactly what we need. And we have enterprise features, in particular access control. So this suits very well to our needs. And if it's the first time you're trying to implement Perforce in a game studio, you might see that there is a bit of resistance, typically from programmers who are these days they're used to a distributed version control environment and using Git and possibly GitHub. But it turns out that they are not the majority of your users, and they are not the case that you're trying to optimize for. Um, However, we will still need to interoperate with Git, as Robert has shown in his talk previously. So we're going to need to solve that problem anyway, typically to work with third-party libraries. And I'm going to show you how we do that ourselves. And also another trade-off that you're going to have to make here is that you're possibly going to have to host Perforce yourself. There are some cloud options, but you most likely want to do that. So I'm gonna go briefly over what we did here. Okay, so now we chose Perforce. Let's see how we set it up. I'm going to take a template game project, which is the shooter game from Epic Games. It's a readily available project from Unreal Engine. And the thing we need to look at here is the project file structure and what are the different specificities with respect to source control and how we want it to behave. So like in any projects, we have some temporary files, things that we don't really want to have in source control. That is fairly typical. One thing that starts being different from pure software projects is that we have binaries in source control. And by this, I mean built executables for the game and the editor. And the reason for that is that the collaborators, which are not programmers, so again, artists and designers, you don't want them to build the game. You want them to just get latest and have all the things that they need to work. So the continuous integration will build and submit the editor and the game binaries into the binaries folder. I'm going to show you that a bit later. And then the art folder is where we store all of the third-party work files. They come from, like I said, third-party applications. It can be Maya, Photoshop, Max, anything like this. It's going to be files that are several hundreds of megabytes large. And in total, you're going to have several terabytes of data into this folder. So the workflow around these files is that you really need to work on a couple of files at a time if you're an artist. And you never really want to have all of these files on your disk. You really don't want to sync this whole folder. And in fact, you probably could not do that because it would be too large for your disk. So how are we going to solve all of that? The way we did it at Darewise is by creating two depots. So here I'm going to create a stream depot for the main project, and that is because we want to use the stream workflow. It's very practical. I'm going to show you the details a bit later, but we're going to involve branching, of course, in our workflow. So streams are the best candidate for that. However, for the art files, we're going to use a regular depot that we're going to separate completely from the main project depot. And in this case, we don't really need branching. And of course, we could do branching in a traditional depot, but we're not even going to use that. Like I said, we're using the streams feature, and I know that not all game studios using Perforce have been using streams, so that may be interesting for you. The reason why we use streams is that streams really allow you to simplify and constrain the branching workflow. So things can only be done in a certain way, which is great. It's very, very good to visualize it. But one of the most interesting properties of stream is that you're able to define the user's workspace view, and you are able to deploy that to all of your users by simply changing the stream specification. So essentially, you're controlling how everyone's workspace looks like. And that's really practical. And it has this awesome feature called Import Plus, which essentially allows you to mount different Perforce locations into that view. So you can combine several repositories into one workspace. So this is how we're setting it up. We start with something pretty typical. You have a mainline stream, which is going to be your main development stream. And it starts with share dot 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 directive. This is the basics. But the one thing we're going to do here is we're going to isolate all of the binaries folder. And the reason for that is that, again, it's a build artifact. It's not very interesting to branch or to merge or to keep any history at all. And so this is just to make branching easier, essentially. So all of your um, semi-temporary files, build artifacts, you want to just isolate in every stream. And now we're going to build the actual stream that artists and designers can work with. And in that stream, we're going to mount, like I mentioned before, using Import Plus, we're going to mount the Shootforce Art depot into the art folder. So in this way, I control that everyone's workspace has this location mounted in the same place. And so all of the relative paths association and all that will always resolve nicely on every workspace. Yeah, so we're creating a virtual stream that has main as a parent, and this means that everything that is submitted in the main project goes into the main stream, and everything that's submitted into the art folder goes into the art depot. So that is perfect. And we're going to ask all of the artists and designers to use as much as possible integrations to avoid human error. We're going to ask them to use the Unreal Perforce integration in our case. And we're going to use P4V only in last resort if you don't have a plugin for the tool that you're using to abstract completely the source control. Some of these plugins are even available from Perforce directly, so you should use them. So this is how it looks like when you scale it up a little bit. Everyone is mostly working on the main streams and doing trunk-based development, and we're pretty much following the stream workflow to the letter with release streams to stabilize our versions. We're doing games as a service, so we have a lot of those. We're avoiding feature streams as much as possible, again, because we have binary files that can't be merged and that contain logic, so it gets very, very hard. And one thing I wanted to show you here, which is maybe counterintuitive, but you can use release streams to represent a foreign code upstream. So the example here is Unreal. When we integrate a new version of Unreal Engine, we're collaborating with Unreal through GitHub. And so we're using this release stream to copy the last state of the GitHub, and then we have a merge stream to maintain our integration with Unreal. So I'm guessing from Robert's presentation that there are better and more integrated ways to do this. But this is sort of a getaway to import a Git repository here. And it's kind of interesting because I know that Epic's working internally with Perforce, but we're still collaborating through Git. So this shows to you how much interoperability is really needed. All right, we still have a couple of configuration to perform on our repository. So all of these temporary files, we want to make sure that nobody submits them by mistake. So we're going to ignore them. We're using the P4 ignore feature, which needs to be set in every client machine. And this is using the git ignore file, so it's very practical. I also know that there's another way to do this using ignore directives on the streams, but I've never personally tried that. So. Then in the content folder, this is actually the binary files used in the game. And in this case, we want to use exclusive blocking here. So I've done an extension mapping here to set all of these files as binary and exclusively locked. But of course, you could also do that by path, and you might as well do that on the art folder as well, because you can't really merge anything there. And then the final one is the binaries. Again, we use the source control here as a delivery system. We don't really care about the history. So we don't want to bloat the depot with a history, a very, very heavy history of binaries. So what we're doing is we're using S32 here, which makes it keep only the last 32 revisions. On top of that, we need programmers to rebuild these binaries locally because they actually are going to change the source and they're going to build that on their own workspace. So we're making those files writable for them. And that's it, basically, for the depot. The only thing that you need to take care of is, of course, to host it. So I just wanted to provide an example configuration for a medium-sized game studio. We're hosting it locally, so on premises, on a server that is what I would call an evolutive server and a starter setup. I know that bigger studios have had issues and have needed to upgrade this, but for us, for now we're pretty happy with that. So we're hosting it on Ubuntu and 64 gigs of RAM, and we have all of our files on regular HDDs actually, and we're not seeing any big performance problems. But of course, it's going to be easy to upgrade this setup later, so you don't have to necessarily invest outfront. Okay, so now that we're set up with our depot, we're going to set up the second pillar of our workflow, which is going to be the continuous integration. And for that, we are using Jenkins ourselves. I'm sure most of you are familiar with Jenkins. It's one of the most popular CI solutions out there. It's free and it has a Perforce Jenkins plugin, which I think Paul was working on or is still working on, perhaps. So yeah, it's officially developed and maintained by Perforce, and you can get support on that. And yeah, Jenkins is a great system because you can always extend it and make it into really whatever you want. So, so it's been very successful for us. Now, there are some specifics about Perforce Jenkins I want to get into because we have a specific depot setup and we need to set up more things for Jenkins to play well with that. And going back to how streams work, streams control the view of every workspace that is working in the stream, and that is sort of a problem for us because maybe we want the build agents to have a different view. Maybe the build agents don't need everything, and especially different jobs might need different views there. So you're going to need to set up what I call a sync stream for the build agents. So I've created here a virtual stream that is still parented to main. And in this stream, I'm going to exclude everything that I don't want the build agent to see. So I don't have anything in particular here. I excluded the art folder just for safety because you don't want to bloat the disk on your build agent, but you could see that this is a way for you to control the view of your build agent. And likewise, we're going to create a submit stream, which is another virtual stream, which is going to be controlling what the build agent can submit. And this one is absolutely necessary because Perforce Jenkins uses a reconcile operation to figure out what it needs to submit, add, or delete. And this might take a really long time. Our current depot is about 300,000 files. And so the reconcile operation is just extremely long. So instead of that, we're going to use the submit stream to perform the reconcile. And in this one, we're going to exclude everything, and we're only going to isolate, which means includes, in this case, the binaries folder. So this means the reconcile operation is now very, very fast. Yeah, so this is how it looks like. You're going to have to set up these streams for every development stream you want to be running CI on. So that's a bit of an extra step. And of course, it means that the CI system is not totally independent. You need setup on the source control side, which is less than ideal. And you'll also probably run into limitations when you start running this at scale, because if you have different jobs that require different views, etc., you will find that maybe this setup is not ideal. So I would recommend to do this as a starter because it's very easy to set it up at first. But if you're encountering any limitations, I would really recommend for you to move out of Perforce Jenkins entirely and start using P4 Python and write essentially all of your scripts in Python calling Perforce commands directly. So there you can do whatever you want. You can sync specifically what you want, reconcile, and submit specifically what you want. There is also P4 Java that's available on Jenkins. The Groovy language that is used by Jenkins has a Perforce Java integration, so you could also use that. But I really recommend Python because you're going to be able to use all of your scripts outside of Jenkins and outside of your CI. So if you want to run a build locally, you just have to run a Python script. So this is really sort of the next step in setting up your CI. And I want to get into a couple of the jobs we're actually using. And this is quite different from most studios. So there's a bit of an opinion here. One thing that I really want in my studio is that there is a really fast iteration between programmers and artists and designers. So when I change something, I want artists and designers to be able to get the result of that as soon as possible. So this is what I call the fast iteration build. We're going to create a trigger, either a push or a pull trigger when code is changed. In our case at Darewise, it's a pull trigger that is triggered every 2 minutes, I think. And it's just going to get latest, build the editor binaries so that people can work in the editor with your latest changes. It's going to build the standalone game executables, and it's going to submit all of this back into the submit stream. So this just means that when I work with an artist, I have something like 7 to 8 minutes turnaround time for them to get my latest changes. So this is as fast as I can make it at this point. It's limited by the compilation time of my project. Then there's a second job that you absolutely need, and that's what I call the playtest build. And this is sort of self-explanatory. You wanna run this at least nightly, and you probably want to have a manual trigger for this as well if someone needs a specific playtest. And in this case, you're going to get latest, you're going to build the standalone game, and then you're going to package it as you would with a Gold Master build of the game. And at this point, if you're doing a multiplayer game like we are, you want to deploy that to your development servers, essentially, to your backend. And the output of the build here is a reference build for QA to start working on, so a daily QA build, or something for reviewers, your creative team, your management team to be looking at. If you're not doing multiplayer, you just at least want to archive these builds so that they can be retrieved at a later point. So again, nothing super fancy. It's just common sense here. But yeah, CI is great, and you should really leverage it as much as you can. I mean, this is not something I should be teaching today, so everyone should know about this. Build and test all of your target platforms as soon as possible, so you make sure that they are compiling and working. Have as many automated tests as possible. In fact, if you're doing C++, you should do static code analysis. You will not regret it. And another thing that's pretty common is to measure some key metrics of the game over time, such as FPS, loading times, number of errors and warnings in the log, so that you can pinpoint change lists that have heavily degraded these metrics. And really, just go all in this. If you have a team that works on CI, then just automate as much as you can. I've never really heard of a story where someone has regretted their investment in CI. So I know that we're not really an industry where unit testing and 100% code coverage is a thing. Testing for games is really hard, but everything that you can test really improves your stability, and it's always worth it. Okay, so now you would be pretty much good to go, but I want to add one more thing, and that is the code review tool. So at Darewise, we're using Helix Swarm as well, and we're very happy with it. And the primary reason we're using it is because it is there. It is free. It is easy to set up. It comes with Perforce, and so it's already integrated. And I didn't see any reason not to use this. We're using this to review every single submit. This is enforced by triggers, and we're using it to review everything, including binary files. And the reason for that is something like some engines like Unreal have logic built into the binary files. So in the end, you must treat that the same that you're treating your code. So you must have the same standards here. But yeah, it's pretty straightforward. I don't have much to say about it. There are improvements that are coming. So even if it's not the best review tool today, it's definitely on its way, and it does the job. So just use it. Don't wait for instability and difficulties to appear. If you want to create a culture of quality, you should do it as early as possible, because it's going to be very hard to climb back that hill once you're down on stability. All right, so I did want to share a couple of extra tips for going further with this. I mentioned we're reviewing all of our assets. And one way to do that with Unreal is to add Unreal as an external diff tool in P4V. So in this way, when someone is creating a review on binary files, you're going to be able to unshelve their change list, either directly their change list or any revision in Swarm, because Swarm creates change list for each revision. So you're going to unshelve that on your workspace and just do a diff with Unreal. So this will allow you to actually diff the binary files. Obviously, you cannot do that in Swarm directly. There are a couple of hidden features that I want to talk about. The first thing is the background users. This is something that is in the Perforce license agreement. You can request 3 extra licenses for essentially users that aren't real people. And you probably want to use these 3 background users anyway. That is for your super admin user, for your Swarm user, which you should keep separate, and for your CI or Jenkins, which you also probably want to keep separate. Yes, so just request that from your reseller or your Perforce support contact. Then there's another feature that is called the spec depot, and I learned about this recently, but it's really useful. It's very easy to activate. You just create a new depot of type spec, and that will allow you to keep track of all the changes in stream specifications or client workspace views. And this will be really useful if you ever want to go back in time, which I found we kind of never really want to do in games. But if you do, you're going to want to know how the stream looked like back then. And so in order to be able to get all the right files. And yeah, finally, I just wanted to give a shout out here for Perforce support. I've been using Perforce for the entirety of my career, and I've been using them a lot, and even more now that I'm building and maintaining my own infrastructure. And they've always been amazing. They go the extra mile. They will, replicate your setup on their machines. They will jump on a call with you and look at your stuff if they need to. So it's always been stellar. It's for me, it's the example of a great support. So if anyone from Perforce support is here, then thank you. And yeah, finally, people have talked about this before, but you really need some sort of disaster recovery. I like the formulation that your crown jewels, your most valuable data is in Perforce. And so if there's anything you need to have very, very solid in your studio, it's your source control. So please back this up, test your recovery solutions. I don't have anything that fancy as a cloud failover, but I have something that will get me back and running in less than a day. And once you have that, you are pretty much done. You have what I would call a state-of-the-art studio setup. And for this, you need to only do this. You don't have to develop any extra tools. I mean, I've seen so many different studios with super complicated setups, but I think what we have built here is pretty much state-of-the-art. You get fast iteration, as fast as possible, in fact. You get continuous integration and as much automation as you need, and you get some enforcement of stability through the code review. So yeah, go out and make games. But yeah, if you're already there, I just wanted to share some extra pointers and extra ideas on what you can do to improve that even further. So like I said, for me, it's really important to keep things lean and to keep things simple. So I'm really building all of my workflow around Perforce because it's my most reliable tool, and it's the only one that I can't really remove anyway. So I'm just gonna automate everything around Perforce. So one thing that we're doing now is we're using triggers to enforce the change list syntax, and this allows us to generate patch notes automatically. It's very, very useful when you're doing games as a service and you're doing releases pretty often. You could build a lot of client-side automation, either client-side on P4V, where you can perform client-side validation pre-commit. But one thing I think is a bit more useful and easier to set up is just to automate all of the project setup and creation. Again, instead of having a documentation to run through, people have to install P4V to set up the workspace in a certain way. There's a bit of human error here. Might just want to automate that using Python. You want to integrate Perforce in as many of your tools as possible. Again, we have people that are not very technical and that would rather have something very abstracted. So we have it in Unreal Engine. If you have a custom engine, you really want to integrate that in your engine. This is, I would say, absolutely critical. And then going the extra mile, you want to integrate that in all of your external tools you're using, such as Photoshop, Maya, ZBrush, things like this. And some of these integrations already exist, either open source or even maintained by Perforce directly. So just leverage that. We already talked about identity providers. So um, at the very least, if you have an identity provider, integrate it, because that's going to just make it easier for you to manage users. In our case, we're using LDAP, but as we've seen, there are a lot of other solutions. And this has also been mentioned before, but leverage the edge servers feature, which are essentially a copy of your whole data and metadata that can be closer to a studio that you're collaborating with, and you're going to collaborate with other studios, especially if you're a small studio like us. So you're going to want to leverage that as soon as you want to scale. This is just going to, again, improve iteration time, which for me is sort of the key metric that I'm trying to optimize here. But yeah, the sky is the limit. Obviously, I still recommend to build everything around Perforce as much as you can, and that's proven to be a reliable way to set up a game studio, essentially. And that's it for me, I guess. Yeah, have fun, and I don't know, Suzanne, if you want me to take questions now. Otherwise, I will wait until the end.
Yes, thank you so much, Samuel. I think the presentation was absolutely brilliant. I think regardless of whether you're in a gaming company or another industry, I think the content that you've actually just covered off there was absolutely fantastic and is relevant to everyone on this call. So thank you very much for taking part. Yeah, so we will open up now for some Q&A for Samuel whilst he's here. If you have any questions, if you could either add them into the Q&A section, that you'll find that at the bottom of your screen, or the chat function. And if you select all panelists and attendees, then that helps us to have everyone on there. So yeah, please do go ahead and put your questions there. And just a reminder, if you don't have any questions right now, or you do think of something at the end, then we do have the full Q&A section at the end of the event.
Either way, I will be sharing my slides publicly as well, so feel free to reach out to me on Twitter or on my personal email at kahncode.com, and I will be happy to help you out.
So we do actually have a question in for you, Samuel, which is, could you explain a bit more about the external diff tool for user assets, please, and what data you get with that?
Yeah, I mean, basically, there is a way to call Unreal in command line, and this opens a lightweight version of the Unreal editor as a diff tool. So basically, what I do when I want to review assets, I unshelve a change list from someone that asks for a review, and then what you have set up in P4V is an extension association for all of the U assets. That is going to call Unreal Engine in this special mode, and it's just going to spawn an Unreal window that is a visual diff. So, of course, if your files are textual, you can use typical diff tools, but in this case, it's a node graph, so it's very, very good that Unreal has provided this first-party tool for this. And yeah, if you have a custom engine and custom file formats there, I would really recommend to build something like this, because it just helps with reviewing critical game data.
Thank you very much. We have two more questions for you. What client-side pre-commit check are you performing, and how did you attach it to P4V?
So I'm not performing any client-side checks yet, but something that you could do is definitely run a small suite of unit tests if you're changing code. The problem is that the majority of things that break with games is usually somewhere in the binary files, and that's very, very hard to do. So I've essentially optimized the studio for iteration time, which means that pre-commit checks kind of get in the way of that. So in our case, we have a sort of a post-commit culture of stability. If you break something, you better fix it fast, or people are going to be angry at you.
Wonderful.
Uh,
Thank you very much, Samuel. Another one is, do you have any experience with other ways of distributing game binaries apart from committing them to the repository?
yes, yes, absolutely. So even Unreal does something a bit different. They use something called Unreal Game Sync. And I've seen this in many, many companies where they build external tools and they have some sort of external storage. And so the CI will archive these builds somewhere else. And then you have some sort of external tool to download a version from that storage. And usually you have some sort of validation there as well. You have this, some versions are validated by QA and considered stable, etc. And I don't think that's necessarily bad, but it's extra investment. So when you're starting from scratch, you want to get something very simple, and more tools or more things to maintain, just more investment in general. So in my case, I just decided to build everything around Perforce. It's a storage system. It's also a delivery system. It's a way to control how user workspace are set up. It's really I think it's just leaner to do it like this. But yeah, there are definitely other ways, usually involving external storages and external tools.
Fabulous. Thank you. So just one more quick question for you is, do you think your HDD performance is good enough for the art assets, or do you think about upgrading to SSDs?
We haven't had any problems so far. Even today, as we're working remote, and again, we have a much simpler way to access our Perforce server. We still have the Perforce server on premises behind our pretty bad internet connection, and it hasn't been a problem so far. But again, it wouldn't be hard to upgrade. So this is kind of the beauty of having your own hardware. But yeah, with the RAID 5 and everything, it's pretty fast. I mean, we're using enterprise grade SATA disks, and it hasn't been a problem. And all of the critical files like database, journal, and things like this are actually on SSDs. So I think, according to the Perforce documentation, anyway, that is the most critical part.
That's fantastic. Thank you so much, Samuel.